Today we're going to talk about compound inequalities, and we're going to go ahead and start with a review of the terms union and intersection. So as you may recall from Algebra 1, union is represented by this U symbol, and it means elements that belong to set A or set B. Okay. So you can kind of think about union as being an or statement. And then intersection, which is denoted with sort of this upside down U symbol, is the set of elements common to both A and B. So those are the kind of key words in each of these. These are and, meaning it has to be part of both, and this is or, which is one or the other. Okay, if we want to think about it in terms of a Venn diagram, which you may be familiar with, if this is our set A and this is set B, the union would be all of this shaded. That would be the union of the sets. Okay? Whereas the difference for intersection, you would have that set A, set B, and the intersection, or the and, would be the overlap, this piece that they have in common. Okay, so let's take a look at an example. I have three sets given here. Set A, which contains the lowercase letters A, B, C, D, E, F. Set B, which contains lowercase letters A, C, E, G, I, K. And set C, which contains lowercase letters G, H, I, J, and K. And then we're going to go ahead and find A union B. So A union B means all of the ones that are contained in both A and B. Okay, so we have A and B and C and D and E and F and G and I and K. So we wouldn't double list them, but we would be sure to list all of the ones that are contained in both A union B. Okay, the difference between A union B and A intersection of B is that if we're considering the intersection, we're considering ones that belong to both set A and set B. So the ones they have in common, essentially. So in this case, A intersection B, or A and B, would be A and C and E. Those are the ones that both contain. Okay? And then lastly, we're going to take a quick look at this. A intersection, or A and C. So if we're looking at that, we're looking for ones that have in common A and C. So what letters, lowercase letters, do they have in common? In this case, they have none in common, so we will go ahead and put the empty set. Okay, for example 2, our sets are x such that x is less than 3, so we're talking about numbers less than 3. And then B is x such that x is greater than or equal to -2, so numbers greater than or equal to -2. And lastly, set C, which has values of x such that x is greater than or equal to 5. Okay, we're going to go ahead and do the same sort of thing. We want A and, or intersection B. So we want the overlap, okay? So if A is all numbers less than 3, let's take a quick look on a number line. So I have the number 3. Okay. And anything less than that would be, and then B is anything greater than or equal to -2. So here's -2. Okay. And then we have greater than or equal to. And essentially, remember, we're looking for the ones contained in both, so that overlap section. So essentially from here to here, these numbers are what these two sets have in common. So in interval notation, that would be everything from -2 to +3, inclusive for -2, exclusive for 3. Okay, I'd like you to go ahead and try B on your own. So pause the video for a second, try B, and then we'll meet back in a moment to start with example 3, letter A. Okay, so let's go ahead and take a look at example 3, letter A. This time it's asking you to find the union or intersection as indicated, so as indicated by the symbol, and write the answer in interval notation. Okay, so again, this first one, we're looking for the union of the sets -2 to infinity, -infinity to -2, and then -4 inclusive to 3 exclusive. So it may or may not be helpful, but you may want to draw a number line to represent each of those scenarios. And then from the number line, you can sometimes see what the union or intersection will be. Okay? So in this particular case, I have -4, and then all the way to 3. In this case, I have -2 as my important mark. Okay, so here I have anything less than -2. And in this particular case, I have greater than or equal to -4, less than 3. Okay, and we're looking for the or statement, so meaning covering everything that both of those sets contain. And so pretty much that means all of it until we get to here. So everything up to here. Okay, so that would be from -infinity to 3. Okay, I'm going to ask you to go ahead and pause the video again, and I'd like you to try example 3, letter B. Okay, and we'll discuss the answer tomorrow in class. All right, the last example that we're going to do is solving compound inequalities. And we are going to just quickly review the idea of union and intersection. So a compound inequality is like a compound statement in an English class. So in ELA, a compound statement is when you have two sentences connected by words such as and or. And in ELA, obviously you have more words than just perhaps and or, but for math, we are going to talk about when they're connected by and today, and then tomorrow we'll talk about what happens when they're connected by or and how those look differently. As we solve here, I'll put some steps on the side for the process, okay? So when you have a compound inequality, that means you have two inequalities that you're dealing with. So your first step will be to solve and graph each inequality. Okay, so we'll go ahead and do that. So let's go ahead and solve this one. We're going to divide by -2. Remember from yesterday's video that when you divide by a negative, we have to switch the inequality. And then we'll go ahead and solve on the side. And so for this one, we will perform inverse operations just like we did here. Subtract 5 from each side, and so I have x is less than or equal to 2. And again, this is an and statement. Okay, so we'll go ahead and graph each of these. Okay, and we're going to graph from -3 exclusive to infinity. Okay, then we'll go ahead and graph the second one. Okay, and we're talking about less than or equal to 2. So we need a bracket for inclusive, and we're going less than. Okay, and then the next step would be to consider the and or. Okay. And then once you have the consideration of whether it's and or, you can decide if you have the intersection of the two sets or if you have the union of the two sets based on that language. Okay, and then your last step would be to express your solution in interval notation. Okay, so we're going to consider our number lines that we just drew here, and we know it's an and statement, so we're looking for the overlap or the intersection of these two sets. So essentially we're considering from here to here. This is what these two sets have in common, so that's the overlap or the intersection. So the overall solution for this particular problem would be -3 exclusive, because it's greater than, to 2 inclusive. Okay, and then we could graph the final solution for the intersection of these sets. Okay, that's it for tonight. I'll see you tomorrow in class.